All right, so yesterday we graphed systems of equations, and we said that if we graph the two lines and they intersect, that intersection point was our solution. If we graph the two lines and they never intersect, then no solution is our answer. And if we graph the two lines and they end up being the same line, it was infinite solution was our answer. Okay, so that's it. Today, we're going to graph a system of inequalities. Okay? And we're going to treat each individual inequality as if it was an equality, because then we don't have to worry about that dividing by a negative rule or multiplying by a negative rule and the inequality flips around. Okay? We have to worry about that. We can just treat it as if it were one. Okay? All right? So we graph them individual like. Okay? So first off, we're going to deal with this one. Y is less than or equal to 3x plus 2. So I'm going to treat it as if it were y equals 3x plus 2. If it's y equals 3x plus 2, how would I graph that? So up 2 from the origin, put a dot. Okay, then what? Right one, yeah, I don't know which way over was. Or I could go down 3, left 1. Right? So on and so forth. And we can get a couple more in there. Then I have to determine, because it is a less than or equal to, I'm going to graph that with a solid line. If it was just a less than or a greater than, I would graph it with a dashed line. Okay? We did some of these first semester, but we just did singleton ones of them. So that's going to go on there with a solid line. With me? Yeah. But now, because it's an inequality, that means it's going to give us a whole range of values. And remember how we said first semester that if we don't go through the origin, we're going to test point the origin. Okay? Right? And so we're going to say to ourselves, so my test point is going to be the origin. So I'm going to plug the origin back into my original inequality. Zero is 0. 3 times 0 is 0. 0 plus 2 is 2. Is that a true statement or is that a false statement? 0 is less than or equal to 2. That's a true statement. So that means that my origin is in the true part, but because I've got to graph another one, I'm just going to put 3 light arrows going in that direction towards where I would have normally shaded on my graph for right now. Okay? Now, I got to remember how I got this one set up. I don't remember if I did I do it like that? Oh yeah, look at that. I already got it set up like that. Perfect. Okay? All right? Then I repeat that process again, but this time now I'm repeating that process for my other inequality. So I say it's y equals negative x plus 4. And now I got to graph that one. Well, that's got a y-intercept of positive 4, so I'm going to go up 4. Put a dot. My slope is negative 1, so that is down 1 and right 1. one and left one. But now, because this one is just less than, no equals component or equals parts to it, this becomes a dashed line. Okay? So when you go to put that one on your graph, this is going to be the hardest part, I promise. I've seen it 18,000 times in the last 20 plus years. Is you're gonna, because you want to just draw that line in there, and then you're like, oh, it needed to be dashed. And so you either got to erase the whole thing and dash it again, or you got to go through and you just got to erase parts. So make sure you know what you're doing, especially if you're choosing to use pen, which motivation pen. Okay? Especially on this stuff. With me? Okay. So then I have to do a test point. I can use the same test point because I didn't go through the origin. The only test points that I can't use are ones that are right directly on that line, solid or dash. Okay? Okay. So I'm going to choose the test point again, 0, 0. So that's going to be 0 greater than negative 0 plus 4. 0 is 0. Negative 0 is 0. Plus 4 is 4. Is that a true statement or is that a false statement? That is a false statement. Alligator likes to eat a bigger number. And 4 is bigger than 0. So that means then that I'm going to be shaded this way. Okay? Now, I would repeat that process if I had a third line or a fourth line. It might happen. You never know. Okay? I don't think I'd ever go anything more than 4. Okay? Okay? Now, the final shading area is where all of your arrows are going, where all of your truthiness lies, which would be over there. And that is your area. Anything in any point that lands in that shaded area makes both of the inequalities true. So it makes the system of inequalities be true. Okay? Handle? Kind of taking stuff we learned first semester and adding another layer to remove 2 on top of 1. Okay? All right, and yep, we did that. So final section we were, I put it in the wrong spot. Sorry, my bad. Right over it. Okay. Love it. You now try number 2 on the back side of your motion. So we got x is greater than or equal to 2. That's going to be a solid line. And that's going to go right there. Okay. My test point, I can still use the origin here for a test point. And that's going to be 0 greater than or equal to 2. And that is false. So that means that I am going to shade right to that line. Agree with me so far on that one? Okay. Then, this one, I'm going to say this is 4x plus 3y equals 12. So that would be 3y equals negative 4x plus 12. This would be y equals negative 4/3 x plus 4. So then that's going to be a positive 4. Then I'm going to go down 4 and write 3. Down 4 and write 3. Down 4 and write 3. I'm also going to go up 4 and left 3. that's going to be a dashed line. Oh, that didn't come out dashed. Why that didn't come out the dash. Then I utilize the test point of the origin again. So that's going to be 4 times 0, which is 0, plus 3 times 0, which is 0. 0 plus 0 is 0, and 0 is less than 12. So that's going to be the bottom side of it, but I'm only really worried about now down here, right? Because up here, it's not going to be in my final answer, so I don't have to worry about that anymore. Okay. Right there, like it. And then lastly, we've got this one. I'm going to treat it as negative 3x plus y equals negative 1. So y is going to equal 3x minus 1. So I'm going to go here, and then 1, 2, and 3 there, 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 1, 2, and 3. Going to also be a dashed line. And then I'm going to test origin, because I didn't go through the origin. Looks like I got close though, but I didn't. Negative 3 times 0 plus 0 is 0. And that is a false statement also. So that means I would shade on this side. So in the end, that area is my answer. Agree? Love it. This one's a little different, okay? So we can handle the y is less than 2. That's going to be what kind of a line? Solid or dashed? Dashed. Without an x, is it vertical or horizontal? It's horizontal, so it's horizontal dashed line at 2. You can still test point the origin. 0 less than 2, is that true? Yep, so we're going straight down. Okay. What kind of a graph, what kind of picture, if you will, is this other one? It's a V, it's an absolute value, it's a V. Okay? Right? So if we remember here, it has a vertex at, in this case, it would be 2, comma, negative 1. Because we think oppositely inside of things in math, and the 2 is inside the absolute value, so it looks like negative 2, so it's going to be positive 2, and then down 1. So there is my vertex. It's got a right side slope of positive 2, so that means I'm going to go up to right 1. Continue that on all the way there. It's got a left side slope of negative 2, but I'm only going to go in the up direction, So because I need to make that V, so it's going to look like that. It's going to be a solid V, or the sides of the V are going to be solid. I can still test point. I can still choose the origin because I didn't go through the origin. But now, instead of which side, it's either going to be inside the V or outside the V. So if I test point the origin, I've got 0 greater than or equal to 2 times the absolute value of 0 minus 2, then minus 1. 0 minus 2 is negative 2. The absolute value of negative 2 is 2 times 2 is 4, minus 1 is 3. 0 is not bigger than or equal to 3. So that means that I'm not going to be on the outside, but instead I am going to be on the inside, but yet below my dash line. So just this little itty bitty triangle right here. Okay? Good times. Now, let's work it going backwards. Okay? So going backwards. So we have just this one single solitary line. Okay? Right? So first off, what you need to figure out from that line is you need to figure out the y-intercept. What is the y-intercept of this line? You have it all on your papers too. It's 3, right? And the y-intercept is 3, so it goes through 0, 3. Okay? So my b is going to be 3. Okay? Then I need to figure out the slope of that line. Rise over run is slope. 1, up 1, right 1, so it's just 1. Okay, love it. So the equation of that line is going to be y equals x plus 3. Agreed? Okay. So that's the equation of the line. We now need to make it become an inequality because we've got shading. Okay. So if I go kind of reverse test point here, my test point is still going to be the origin. So if I plug in the origin into that equation, I get 0, and I'm going to leave the box open for now, but then I would have 0 plus 3. So that's going to be 0 and 3. I need that to be a true statement, right? Less than or equal to is going to go in here, like that, to make it a true statement. The equals part gets me the solid line. So this system right here would be y is less than or equal to x plus 3. See how I kind of reverse engineered that? Okay. All right. Let's try it here on number 5 now. I will tell you that I am lazy, so this line right here is the same as that one. So that one is going to be y is less than or equal to x plus 3. That's the line of the slant. Okay. The other line is vertical, right? So our vertical line's x equals or y equals? X equals, so this is an x equals 3 line. So we want to put, because our test point would be here then. So if we put in 0 and then 3, We want that to be a false statement, right? So we want to go that way with no equals component? Exactly. So we would say here then that this would be x is greater than. And those two together then is that system. With me? That is really all that I got for you today, because I think we're at the end of our note sheet, which we are at the end of our note sheet. You have a yellow homework that goes along with this week. You've got 2 graphing equations from yesterday and 2 graphing inequalities from today. That is due tomorrow. You will have a formative tomorrow, roughly in the same, it'll have 4 problems on it tomorrow.